Hi students, we are discussing how to write essay type answer for slow learners in the physics exam. So this is regarding the derivation of electric potential at a point due to an electric dipole. So as you shall know, you will have to draw the diagram first. So AB is an electric dipole where minus Q and plus Q charge you have to draw. So we have already discussed that left side is negative charge always, right side is a positive charge. O is the midpoint. So the distance between A and B is what? A plus A is equal to 2A. Now at a point C in space, what is the electric potential due to two charges, and finally due to the electric dipole we have to find out. Now you join the point C from the positive charge at a distance R1 and join C from A, that is from the negative charge, at a distance R2, and join the point C with the midpoint O of the dipole, which is at a distance R. So we have to express R in terms of R1 and R2, that is R1 and R2 must be expressed in terms of the distance R. Okay, so you first draw the diagram correctly. Now OC is that straight line which makes an angle theta on the right side and 180 minus theta on the left side. Correctly you have to mark the angles. Okay, now in this next passage you are going to just do the summary of the description of the diagram. So AB represents electric dipole. Minus Q and plus Q are the two charges. R1 is the distance of C from plus Q. R2 is the distance of C from minus Q. R is the distance of C from the midpoint O. Very simple. Are you gaining confidence now? Describe the diagram. Then 2A is the distance between the two charges. And P is the electric dipole moment, which is equal to the distance 2A and any one of its magnitude Q. Now, as usual here children, at point C there will be two potentials, one due to the positive charge and one due to the negative charge, and the net potential is the sum of the two potentials. Very simple. So start with the first potential at C due to this positive charge plus Q, that is denoted with the symbol V1. So that is 1 by 4 pi epsilon naught into plus Q divided by R1. Okay, positive charge. So this is equation 1. Similarly, the potential at C due to negative charge minus Q, that is 1 by 4 pi epsilon naught into minus Q by R2. Okay, minus Q because it is a negative charge. Now the total potential at the point C, that must be naturally equal to V1 plus V2. So V is equal to V1 plus V2. Now in V1 as well as V2, Q by 4 pi epsilon naught is common factor I have taken out. So remaining term is 1 by R1 in equation 1 and minus 1 by R2 in equation 2. So that I have written 1 by R1 minus 1 by R2. So you call it as a equation 3. Up to 3, are you understanding now? Systematically. So potential V1 is positive, potential V2 is negative, and the net potential is Q by 4 pi epsilon naught into 1 by R1 minus 1 by R2. Okay, now we have to express this R1 and R2 in terms of the distance R. Then only we can add and get the net potential. So for that, look at this picture. Now right side there is one triangle. Okay, so this is a BOC. If it is a right angled triangle, means then according to Pythagoras theorem, R1 square must be equal to what? R square plus A square, is it not? If it is a right angled triangle, but this is not a right angled triangle, it is a scalene triangle. Therefore now I am going to apply cosine rule. Cosine rule. So when I apply cosine rule to this triangle, apply cosine rule in triangle BOC. So BOC. So this side Okay, opposite to this angle theta, opposite to angle theta, r1 square, you see here, r1 square must be equal to r square plus a square minus 2ra, 2ar into cos of this theta. Okay, minus 2ar into cos of theta. Up to this, compulsorily you will have to write in the examination. You can't skip this step. So you have to mention, apply cosine rule to triangle BOC. This step you have to write. After that, if you wish, you expand by taking r square as the common factor. When I take r square as the common factor, inside the bracket the first term will be 1. So 1 into r square is r square. Plus the second term is a square by r square. Minus 2ar cos theta by r square. Okay. So up to this step. Now this a square by r square term can be neglected because this distance a is very much less comparing to r. Therefore a square is very much less comparing to r square. Therefore this a square by r square is neglected. So the remaining terms only I am going to write. So here 2ar cos theta by r square, this r and power square get cancelled. So now r1 square is equal to what? R square into 1 minus 2a cos theta by r. Up to this, if you write, you will be getting full marks. There is no chance of cutting even a half mark also. But after this, definitely you go by shortcut. Okay, all the steps you need not write in the exam. Now after this, what we are going to do? 3 steps. One is, I will take the square root first. Okay, square root. And then I will take the reciprocal and expand using binomial expansion. So you write a single statement taking square root, reciprocal and expanding binomially. It can be shown that 1 by r1 is equal to 1 by r into 1 plus a cos theta by r. Very important equation, you cannot skip this. Write this and practice many times. So 1 by r1 is equal to 1 by r into 1 plus a cos theta by r. This is equation 4. Suppose in between steps you are feeling very difficult, means don't worry at all. Directly you write, applying cosine rule in triangle BOC, it can be shown that 1 by r is equal to 1 by r into 1 plus a cos theta by r. You write boldly, you will be given considerable marks. Understand? Definitely you won't lose full mark. So they may consider this sometimes. So applying cosine rule in triangle BOC, equation 4. Similarly, you apply cosine rule to the other triangle AOC. Here the angle is 180 minus theta. Side opposite to that is R2. Therefore R2 square must be equal to what? R square plus A square minus 2AR into cos of 180 minus theta. Cos 180 minus theta is minus cos theta. So I have written very shortly. It can be shown that 1 by r2 is equal to 1 by r into 1 minus a cos theta by r. So you recall up to equation 3, you read, you write, then applying cosine rule in triangle BOC, straight away you write equation 4. Next, applying cosine rule to the triangle AOC, straight away you go for equation 5 because it's a very lengthy derivation. So up to 5 equations only you write. In between working out, you don't write because you are all slow winners. Okay. So now after equation 5, once again you take the equation 3, V, the net potential, total potential, V equal to Q by 4 pi epsilon naught into 1 by R1 minus 1 by R2. Instead of 1 by R1 equation 4 and instead of 1 by R2 equation 5, if you substitute, you see here Q by 4 pi epsilon naught into 1 by R will be a common factor. After that, only this quantity in bracket has to be written inside. So 1 plus a cos theta by r minus of 1 minus a cos theta by r. When you open up this bracket, this 1 and minus 1 get cancelled. Then minus of minus a cos theta will become plus a cos theta. So a cos theta by r plus a cos theta by r will be 2a cos theta by r. But already Q by 4 pi epsilon naught r is there outside. Don't forget, here one r term is there. So now I take this Q by r inside the bracket. The remaining is 1 by 4 pi epsilon naught into 2aq, this 2a into q separately I have written, cos theta separately I have written. So 2aq cos theta by r into r is r square. Here many students will skip this term r, they forget. So this r into r is r square, keep it in mind, okay. So r square, final equation, denominator should contain r square term. Okay children, now this 2aq, okay, 2aq is nothing but small p, that is dipole moment vector. So instead of this 2aq I can write p. So p cos theta by r square, I have written p cos theta by r square. That is the final step actually in scalar form, because electric potential is a scalar only. In scalar form it is what, 1 by 4 pi epsilon naught p cos theta by r square. So scalar form, that is equation 6. Suppose the dot product of two vectors, the dot product of two vectors is also a scalar. That is why in the dot product of two vectors also I can express. So once again V is equal to 1 by 4 pi epsilon naught into p vector dot product r cap, unit vector r cap divided by r square. Understand? This is in vector form, is equation 7. So the derivation is over. But on the safer side, always in exam you write some special cases. Suppose if this point C lies along the axial line to the right side of the positive charge, then theta will be 0. Suppose if C is lying on the left side along the axial line, on the left side of minus q, then the angle will be 180 degree. Theta is 180. Or suppose if C is right angle, C is lying on the equatorial line, equatorial plane, understood? Then the value of theta is 90 degree. So these are the special cases. You write this also in practice, it will be very easy only. So case 1 is what, theta is equal to 0, cos theta is cos 0 is equal to 1. Therefore here cos theta will become 1. So it is positive. You get V equal to plus p by 4 pi epsilon naught r square. That is equation 8. Suppose you take theta is 180 degree. Okay, cos 180 is minus 1. Therefore, V is equal to minus p by 4 pi epsilon naught r square. That is equation 9. And if theta is 90 degree, then cos 90 is equal to 0. Therefore, the potential is equal to 0 along the equatorial line at any distance. Okay, so you started with a diagram, description of the diagram, then potential due to positive charge, due to negative charge, then adding these two, then expressing 1 by r1 in terms of 1 by r using cosine rule. Next, expressing 1 by r2 in terms of 1 by r using cosine rule. We have got the final equation in scalar form as well as vector form. Finally, you end with the special cases also, so that pakka, this is a 5-mark question, okay, so very lengthy. Therefore equations 4 and 5 directly if you write also, it will be considered. Don't think it is difficult, everything is easy only. Wish you success.